The next concept is Standard Normal Variate Z. So let us define what is Standard Normal Variate is. So it is often written as small z or a small z. So Z is basically a Gaussian distributed random variable with a mean of 0 and a variance of 1. So you have a random variable like small z or z with a mean of 0 and a variance of 1. That is called Standard Normal Variate. This particular thing is called Standard Normal Variate. So we will see why it is called standard and why it is useful. So this is the first thing. Now the second thing here is, let us understand it. Let's suppose I have a random variable x which is Gaussian with a mean of mu and a variance of sigma square. Let us assume I sampled some points from this distribution. Fine. And let us assume that this x is basically my petal length. So let us assume I have 50 petal lengths that I have taken from this distribution x. So here x1, x2 till let's say x50. Fine. Now all these are observations from this random variable x. So these random variables x can take multiple values. Let us assume that there are 50 values that I have sampled from this random variable x. Now given these observations of this random variable x, I can standardize these values. So for that I can apply a transformation called standardization. So let's write standardization. Fine. Now, one thing to remember is that these random variables have a mean of mu and a variance of sigma square. So the way we can simply standardize this for every variable xi here, let us define a new variable xi dash such that xi dash equals to xi minus mean mu by standard deviation sigma. Here each of the xi is equal to 1, 2 till 50. So if xi's come from normal distribution with a mean of mu and a variance of sigma square, xi dash will come from normal distribution with a mean of 0 and a variance of 1. So my xi dash here is basically standard normal variate. Fine. In other words, given any distribution, that is given any random variable, let's say x, with a mean of mu and a variance of sigma square, I can convert into standard normal variate z by subtracting mu from the values of x and dividing it by sigma. So as soon as we do this, we can say that z is basically a random variable with a distribution of 0, 1. That is with a mean of 0 and a variance of 1. Such an operation is called standardization of data. This is called standardization. standardization of data. So for example, if you are given 50 values of petal length, you can standardize them by subtracting the mean of all of these values from x and dividing it by standard deviation. Here, you are transforming your 50 observations into 50 other observations, right? For each of the I equal to 1, 2, so and so forth till 50. These are your actual observations, Fine. So these are your actual observations and you are transforming them into xi dashes such that xi dash has a mean of 0 and a variance of or a standard deviation of 1, right? Having said that, now you might ask, why are we even normalizing or why are we standardizing this data? What is the point of standardizing? So given any random variable x, for this let me draw a Gaussian distribution first. So given any random variable x with any mean and sigma square, the moment I standardize my data, the moment I standardize it, I know that between 0 and 1 or between 0 and minus 1, 34% of my data lies. 34.1% of my data lies. And if we can say between minus 1 to plus 1, I can say 68% of my data lies. So if you tell me that x is a normal distributed random variable with a mean of mu and sigma square, and if I just simply apply my standardization operation, whatever values of z I can get after standardization, 68% of xi dash lie between minus 1 and plus 1. And I also know that 95% of xi dash lie between minus 2 and plus 2. Fine. So standardization is a good method wherein I can transform any random variable x with any mean and variance into a standard form. Is a mean of 0 and a variance of 1. So this is called standardization. And this is basically to say that given any random variable, I want to convert to the standard format. Because once I convert to the standard format, I know exactly that a few properties of a standard normal variate like small z or capital Z here that I can quickly understand and interpret. So this is all for the day's lecture. Hope guys you have enjoyed this session. If you really like this session, don't forget to subscribe the channel and keep commenting your doubts in the comment section and keep suggesting me how I can improve your learning experience. Thanks, take care, see you in the next session.